Hello, good morning everyone. So today I'm going to make you a video about reviewing the topic for a complex number and also for the circle equation for the preparation for these end semester tests. So let's start from the first question, the simplify the expression below into the simplest form. Now see that we have this one here, a lot of question here. Now when we go back again to the basic concept is that the I is, remember that that'll be the square root of -1. So if I have I squared, that'll be like square root of 1 times square root of 1. Square root of -1 times square root of -1, and it'll be just equals to -1. If I go to I to the power of 3, that'll be I to the power of, I can write down an I squared times I to the power of 1. That'll be just like this multiplied by this, and you'll get the square root of, not square root, it's negative I. And then the last one is I to the power of 4, they'll be just a squared times I squared, right? So this one here multiplied by itself, -1 times -1 is equals to 1. So if you go to the next term, like I to the power of 5, you'll actually eventually going back here. So this is just equals to I, right? So it's just I, and if I go to 6 over 6, it'll be this guy, -1, and then so on, so on, right? So that'll be negative I, and then equals to 1. So you can see that it rotates, because we know that in the Argand diagrams, right? So when we multiply by I, it just like rotates the number like that, right? So you're actually going, yeah, in cycle. Now when we want to find out what is the value of like a complex number to the power of some numbers, you can actually like see the power, like use the long division, for example, and then see what's the remainder. If the remainder is 0, so that'll be just 1. If the remainder is 1, so it's going to be I, the remainder is 2, that'll be this guy, the remainder is 3 is this guy, and then the remainder of 0, you go here. Yeah, so let me give you the example. So here we have the first question, A is I to the power of 7. So this is actually this negative I. So I can do it like this. If I do the long division, for example, like that, right? So 7 divided by 4 is just 1, and you get 4, and then see you get 3, right? So this is the remainder. Can you see that this number is smaller than 4? Can you see that this 3 here, right, it's like, you see the power, here, 3, that'll be just negative 1. You see that this negative 1, right? Now the same thing here, be careful that this 7 here is just 7. I mean, like, this is just 7 multiplied by I to the power of 9. So if you want to know what is I to the power of 9 in terms of I -1 negative I over 1, so you can do the same thing like this one over here, like just 9 divided by 4, you know, like it's 2, and then 8, and then you see that the remainder is 1. So if the remainder is 1, so this is actually, you know that this is I. If I say I, it's actually I to the power of 1. So that's just, that's it, right? So it's basically the same thing as 7 times I. That'll be just 7I. Now same thing here, right? So we have this I to the power of 3, and we know that I to the power of 3 is negative I. So it's the same thing like 4 times negative I. That'll be just negative 4. Okay. So the same thing like we did for question C here, 6I to the power of 12. Can you see that 12 is divisible by 4, right? Which means that we have a remainder of 0. So we have a remainder of 0, so it's the multiple of 4, so that'll be just equals to 1 for this I to the power of 12. So this is basically just 6 times 1, which is equals to 6. Now for the next question, be careful with this one, because you have a bracket and then you have a power, right? So including all of them. Now when you do this, this is actually, remember, in exponent, 2i all being squared, it means that it's 2i times 2i, right? So you're just multiplying the number inside the thing inside the bracket by itself 2 times, right? So if I multiply that, you get 4i squared, right? Now remember that I squared is just -1, so that'll be just 4 times -1. That'll be just equals to -4. Now the same thing for question 3 here, same thing like that. So we can actually use what we call the exponent rule, right? So this 3 here, this power goes to 3 and goes to the I, right? So I can write down as 3 to the power of 3 times I to the power of 3. Now 3 to the power of 3 is just 27, and I know that I to the power of 3 is this guy over here, which is negative I, and then that will be just equals to negative 27I. Okay, so for question number 2, determine the possible values of x from these equation. Now, if you see a quadratic like this, guys, so this is pretty easy for question A and B. You can just like isolate the x by itself by, for example, like subtracting both sides by 1, right? -1, -1 here. So you will get x squared equals to -1. And you see that x squared equals -1, meaning that x is equals to plus minus the square root of -1. And we already know that the square root of -1 is just I. So the first question will be plus minus I. That's it. Now the second question here, we have x squared minus 50. This is basically the same thing like this, right? So you see that if we have x squared equals to -50, so x will be equals to plus minus, again, the square root of -50. And you can actually split this up, right? So it becomes some multiplication of like numbers which can be what do you call it, the perfect square, for example. Now we have that guy is like -20, sorry, I'm going to 25 times 2, right? Because 50 is 25 times 2. But remember that this is a negative, so we multiply by -1. Now, if you split everything here, we have plus minus. The square root of 25 is just 5. The square root of 2 is just square root of 2, but the square root of -1 is, so there you go. As for the next question, question C, so you can't do it like question A and B, which like you only need to like isolate the x squared by itself. Pretty easy. For this one is a quadratic, so sometimes in quadratic you cannot factorize, so that is why you need the formula. So the formula to find the x value, so the subject value of the quadratic will be negative b plus minus square root of b squared minus 4ac over 2ac. So this is a very general formula. I recommend that you memorize this. And you see that we need to determine the value of a, b, and c first before we plug in the numbers over here. Now remember that when you write it down, when you pick the a, b, and c, it needs to be in order in descending power of x. Yeah, this one is because the subject is x. Yeah, so we have to the power of 2. This is actually to the power of 1. So actually here we have x to the power of 0, but we don't want to write it down. Now, which means that the value of a is just 1, the value of b is 1, the value of c is 2. Yeah, okay, so just plug in everything into this formula, and you will get -1 plus minus the square root of 1 squared, and then minus 4 times 1 times 2, and then divided by 2 times 1. Okay, so let's do it again. So -1 plus minus, you see that this is just 1, and this is 8, right? So this is -8. So 1 minus 8 is equals to -7. So that will be square root of -7 and divided by 2. Can you see that again? This is like negative. If you see a negative inside the square root, you can just split them, it becomes I. So we can write down as 1 plus minus the square root of 7i, because we know that this is square root of 7 times, so this one here is the square root of 7 times -1. So the square root of -1 becomes the I, and then over to, if you cannot simplify it, so this is the final answer. So for question D, this is the same thing as before, but remember that the form of the quadratic should be in the form of ax squared plus bx plus c equals 0. Can you see that this guy is not equal 0? So it should be equal 0. So we need to add both sides by 2 to remove this -2. So you'll get 3x squared minus 2x plus 2 equals 0. Okay, this guy comes here. Now we can do the same thing like before, right? So we get -b plus minus square root of b squared minus 4ac over 2a, right? So just plug in, we have -2, that'll be just 2, plus minus square root of b squared, this b squared is just 4, minus 4 times the a is 3, and the c is 2. Okay, and then over 2 times 3, okay, so the a is 3. Now if you calculate that, you'll get plus minus, this is 24, and that'll be -20, right, over 6, right? 4 times this is 20, is it? 4 times 3 is 12, 12 times 3, yeah, this is. Yeah. So again, you see that this is -20, the square root of -20 is equals to the square root of 4 times 5 times -1, right? So the 4 becomes 2, and this is just square root of 5, and this becomes I. So you can write down as 2 plus minus 2 square root of 5 of I over 6. But you can see that every single of the term is divisible by 2. So the case of question C, we have z equals 3 minus 2i, and w equals to -4 plus I. So those are just a complex number, and we need to add, subtract, multiply, maybe divide later on, right? So this is like a pretty basic algebra actually, guys. When we want to add like like algebraic expression or yeah, complex number, we can just like see the like terms, and then we to see if we can combine them. So for example, this is z is 3 minus 2i, and the w is plus, right? So it's plus negative 4 plus I. So I suggest that you actually need to put brackets on it. But if it's just addition, you don't really need to do that. But if it's subtraction, you do that. Yeah. But yeah, for now, for the sake of like the educational purposes, so I'm going to put the bracket so you can actually move that. And then 3 plus negative 4, that'll be just negative 1. And then negative 2i plus I will be just negative 1i. That's it. Pretty simple, right? Now for question B, now this is the part where the bracket plays a very important role. So when you see that if I do that, if I move, I have a negative here. Actually, we have a number here which is 1, negative 1. So when you want to open the bracket, so you have to multiply this negative 1 into each of the term inside the bracket. So if I have that, I don't actually I have 1 over here, but 1 times any number is just like going back to the same number. So we can write this down as 3 minus 2i. And then this guy here is negative 1 times negative 1 is to be plus 4. And then negative I times negative 1 times I will be negative I. And the same thing like we did before, so it's 3 plus 4, which is equals to 7. And then negative 2i minus I, that'll be negative 3i. Okay. Next one is multiplication. Then again, same thing when we do like opening brackets in multiplication, that'll be 3 minus 2i. Then again, guys, bracket, very, very important. And then plus 4i. And then we can do the FOIL method if you remember, like this 1, 2, 3, 4, right? So let's do one by one. So 3 times negative 4 is equals to negative 12. And the next one is this times this, that'll be just plus 3i. And then this plus times this, that'll be plus 8i. And last one is this times this, that'll be negative 2i squared. And this is very, very important. Now, because we know that I times I is I squared. So if we go back to the previous question about I squared, what is I squared? I squared is just negative 1. So I'm going to rewrite that again. 12 plus, I'm going to just add these two numbers here because they are like terms. 3i plus 8i is equals to 11i. So this one here becomes negative 2 times negative 1 because this guy is equals to negative 1. If we add, multiply this, you get plus 2, right? So that'll be negative 12 plus 11i. This is plus 2. And we can combine these two numbers here because they are like term. They'll be negative 10 plus 11i. For the next question, we have z divided by w. So I'm going to write down like that. So when we want to simplify this expression here, now notice that remember that when you learn about surds, for example, if I have, for example, like 2 over square root of 3, for example, now you're being told, most of the time you're being told how to get rid of this square root in for the denominator. This is actually the same exact concept, yeah. And you see that we have, for example, if I have like 2 over 1 plus square root of 3. So how do I get rid of this for the denominator? I multiplied it by the conjugate. If you saw the conjugate is like this expression here, but if it's plus, the conjugate is just minus. It's 1 minus square root of 3 over 1 minus square root of 3. So why do we need to do that? Because in the concept of like algebra, if I have a plus b times a minus b, they'll be equal to a squared minus b squared. Can you say that if we're squaring numbers, the square root will be gone, right? So for example, like square root of 3 all b squared, they'll be just equals to 3, right? So we're getting rid of that. Now again, we can use the conjugate. Be just like if this is like plus, then this is the minus. Okay, so let's go back again to the question here. We have 3 minus 2i over negative 4 plus I. So what you need to focus on for right now is this guy over here. So you need to find the conjugate of this expression, and it'll be just negative 4 minus I over the negative 4 minus I. So can you see that I'm multiplying with this fraction, which actually just equals to 1, right? Because any number divided by the same number except 0 is equals to 1, right? So it doesn't change the value of this. Yeah. Now again, can you see that just like multiplying? If I do this, remember what I've just explained. Now this is just like a plus b times a minus b. So that'll be just equals to negative 4 all being squared and minus I all being squared, right? So that's for the denominator. Now as for the numerator, we can do it the same thing like we did for the multiplication, right? So you can do it like that, right? And if we do that, I'm just going to go straight to have negative 12 and then a negative 3i, and then plus 8i, and the last one is plus 2i squared. Now let's simplify what we have here. That'll be equals to this guy and this guy here. So that'll be plus 5i, just plus 5i. And then this guy again, remember that this I squared is just negative 1. So 2 times negative 1 is just negative 2. So negative 12, negative 2, that'll be negative 14. Right? So negative 14 plus 5i. And one on the denominator, we know that this is 16 and this is minus 1. Right? So that will be 16 minus negative 1, that will be just equals to 17. Now you see that in this expression, you see that you can't simplify it anymore. So this is going to be the final answer. Okay, now for question E and F, I'm gonna leave it, guys. Leave this question for you guys because yeah, I think you can do it by yourself. You can just like see the example like this one over here. So like for example, like 3w is just like 3 multiplied by all the terms in this w here, and so on. So on. Okay. Okay, number 4. Determine the variable of a and b, which fulfill this equation here, right? So you see that we have a multiplication of like 2 complex numbers and then equals to that. Okay, now what you should do is just like, okay, just multiply this out and then see what you get from the right side. For example, if I have ax equals to 2x, what is a? A is just 2 because we know that this is like, okay, this is x and this is x. That's it, right? So you only need to match them, match the form from the left and on the right side. Now let's do what we got. What we have here, we have a times 2, we have 2a, and then a times negative I, they'll be negative ai, and then this one here plus 4i, and the last one is this one here, negative 2i squared. Now let's simplify what we have here. 2a minus ai plus 4i, we can actually write it down as plus 4 minus a of I, right? So see, because why? Because we have 4 minus a, this one over here, and then we have I. Yeah, so it's just the same thing as factoring. Now we know that this is negative 1, so negative 2 times negative 1 is equals to 2. Yes, just plus 2. And you see that this guy and this guy, both of them doesn't have any I, so let's just write down, let's write that down side by side. So 2a plus 2 plus 4 minus a, and then I. Can you see if I write down here, they'll be equals to 4 plus bi from here, and you can just like match them up. For example, this one here is the real part, which is equals to 4. So I can recreate another equation, which is 2a plus 2, which is this guy, is equals to this guy over here, right? So this is a very simple algebra, right? So subtract both sides by 2, you get 4 minus 2, which is 2, and then divide both sides by 2, we get equals to 1. Okay, now the same thing goes to the b, right? So if we say b of I here, so this is the imaginary part, right? So we can say that, oh, this guy here is equals to b, right? So let's rewrite another equation from that. So we have 4 minus a is equals to b. Now we already know that the a is equals to 1, so plug in 1 here. So 4 minus 1 equals b, so b is just equals to 3. Okay, so for question B, I'm gonna leave it to you guys. Please do it by yourself, and it has the same exact concept like we did, like I just explained for question A. Okay. Number 5, determine the complex number of z x plus iy, which fulfill this equation over here. Now you see that we have z over here, and then we have z, and then we have a star over there. So what does that star mean? It means that that is the conjugate. So if z equals to x plus iy, so z star is equals to x minus iy. Now what we need to do is just like substitute that z into x plus iy, and then this guy becomes this guy, and then see if you can spot on like a pattern, and then solve the value of x and y here. Okay, so let's do that. Now this guy here is just x plus iy. This guy is just plus 3i, and then the next right on the right side will be 2 bracket. Don't forget the bracket here, the conjugate of z, which is this guy, and that'll be x minus iy, and then plus 4. Okay, now let's try to what do you call it, grouping. Yeah, so we have the real part and the imaginary part. So this is the real part because it doesn't consist any I. So these two are the imaginary part. So I can write this down as x plus bracket y plus 3 of I. So I can like pull out the I, right? Factoring like this. Okay, for this one here, we need to multiply them first, right? So we get equals to 2x minus 2yi. Iy and yi is the same thing. I'm just going to put the I on the back. And then plus 4. Okay, now again, I can group this down in terms of the real part and the imaginary part. So these two are the real part because it doesn't have any I, right? So let's rewrite that again. I'm going to write down 2x plus 4, this guy and this guy. And then minus 2yi. Okay, now I'm going to rewrite the one on the left side. And then again, the same thing like before, we need to match them up. So here, the real part is this one, and this is the real part, it's that one over there. So which means that we can write down another equation, that will be x equals to 2x plus 4, right? This guy is equals to this guy, okay? So let's just solve this equation. Okay, subtract both sides by x and then subtract both sides by 4, and you'll get like this, 2x minus x, and then this becomes negative 4 over here. So 2x minus x is just x, and we have the value of x. Okay, now that leaves us with the y value here. We have the imaginary part, which is this one, which is equals to this one. So you can leave the I alone because you have already they call it pull it out, yeah, factorize them. So which means that this y plus 3 will be equals to negative 2y. So let's recreate the equation again. So we have y plus 3 equals to negative 2y. I'm gonna add both sides by 2y. So for example, like y plus 2y, and I'm gonna subtract both sides by 3, and you'll get something like this, yeah. So it's like this going this way, and then this going that way. So and then y plus 2y is just 3y. And then this is negative 3, and then divide both sides by 3, you get negative 1. So which means that the z is equals to, yeah, okay, we know that the z is this guy over here, right? X plus iy. Since we already know the value of x and y, so that will be x, it will be negative 4, and then plus negative I, or just negative. That's it. For question B, for question B, I'm going to leave it to you guys. You can do it by yourself, right? The same thing like we did over here, just match them up. Okay, for number 6, so we have z and w like that. The question is to show the coordinates of each of the complex number in the Argand diagram like this. Okay, so for example, like z here, we have 3 minus 2i. So basically, again, guys, the real part is like the x-axis in the Cartesian plane, and the one that has height I, that will be like the y part. So you can see that the coordinate of z is just 3, negative 2. That's it. 3, negative 2. So if I 1, 2, 3, and then negative 2 is over here, right? So the Argand diagram where that z is just like making a line from the origin going that way. That's it. Yeah. So this is the z. Yeah. So if you see the factor is fine. I mean, like if it's just the coordinate, so it's just that. Yeah. So that's it. So this is z. And the same goes with the other. For example, this is like going to be 3 plus 2i, right? Because that's the conjugate of the 3 plus minus 2i. And the same thing like everything here. So you can just like do the operation first and then try to plug that into, I mean, like you see the coordinates and then plus it in, right? But this is pretty easy actually. You can do it by yourself. Okay, for number 7, determine the complex number in the form of the polar form r-tis theta. So remember that r-tis theta means you have r and then bracket cosine theta plus I sine theta. So this is what actually happened. See that the r is the modulus, it's like the length of the what do you call it, the complex number. Like we go back again here, for example, like the length, if this is like from here to here, what's the length of this line here? So that is the modulo. And then the theta here is the angle. So for example, if I have 3 plus 2i here, so this, let's go back again to number 6. 3 plus 2i is over here, right? So the length here, we can actually just use the Pythagoras, right? So this is pretty easy again, guys. And then as for the theta, is the angle that shapes from the real part. So it's this angle over here. So we can use the tangent the ratio, trigonometric ratio, which is tangent, because we already know the x value and the y value, right? This is like the adjacent and the opposite, right? This is the adjacent, this is the opposite, and then we can try to find out the theta. Okay, now for example, here we have 4i. So can you see that we don't have any real part? So I can actually write it down as 0 plus 4i, right? So this is the real part and this is the imaginary part. If you draw it in Argand diagram, they'll be just here, right? This is 4. Now this is very easy because the length is just 4, right? Because that's just like a vertical line, right? So it goes from 0 to 4, so the modulus, or the R value, is just equals to 4. Now in terms of the angle, this is also going to be pretty easy, because if you see that from the real to imaginary here, you see that this angle is just 90 degree, but in here, remember that you're going to use the radian, so this will be in pi over 2. So for the first question, that'll be 4 and then just pi on 2. Yeah, so pretty easy. Now question B, on the other hand, we have like the angle is going to be different. So let's talk for the module first, the R value. So remember that this is just like X and Y. So when you want to find the R value, it's just like the same thing like using Pythagoras. The C squared equals to A squared plus B squared, if you remember. So the C is basically just the R value. So if I do that, there'll be the R, I'm just going to go, there'll be the square root of 2 squared, this guy, and then plus this guy also plus 2 squared. Now if you open this bracket, there'll be 4 plus 4, which is the square root of 8, or you can write down as 2 square root of 2. Now how about the angle? The angle shape is going to be, the theta is going to be the tangent inverse of the y over x. Remember, do not switch it. This is y, this is x, because this is the opposite and this is the adjacent, yeah? So don't forget this, the one that has the I first and then the other part. Yeah. So there'll be 2 over 2. Right? 2 over 2. And then that'll be just equals to 45 degree, right? Because we know that tangent of an angle equals 1, there'll be 45 degree. Or in radian, there'll be pi on 4. So if we write down the polar form of this question here, there'll be just 2 square root of 2 and then just pi on 4. So this is the answer for question B. Now let's go to question C, and here be careful that if you have a negative, yeah, you need to determine where the quadrant is. Okay, here. Now you see the first one is negative 5 square root of 3 plus 5s. So be careful with determining the argument or the angle here, and that is from here. So we have the x value, like the real part is a negative, and then the imaginary part is positive. When you go to the Argand diagram, the negative 5 over 3 is over here, right, and the plus 5 is over here, so you go there. So you're going to be in the second quadrant. It means that the angle should be more than 90 degree or more than pi and 2, or less than 180 degree or less than pi, right? So be careful with that. Now let's go to the R first. So the R value will be just equals to the square root of this guy, all being squared. So negative 5 square root of 3, all being squared. And then plus this guy being squared. So it's 5 all being squared. And then you open this, that'll be 75. The square root of 75. Yeah, square root 5 square root of 3 square is 75. This being squared is 25, and you see that this is equals to square root of 100, which is just equals to 10. Yeah. Now let's go to the theta. There'll be the tangent inverse. Remember that the y goes first, and then the y and then the x. Yeah. So there'll be 5 divided by negative 5 square root of 3, and you'll get 5 over negative 5 square root of 3, and you see that you can cancel that, and there'll be just tangent inverse. So this is tangent inverse of 1 over square root of 3 negative. Yeah. So if you don't really remember the what do you call it, the special angle, you can actually use the table like sine, cosine, that 0, 30, 45, 60, and so on, right? I'm going to write down the place 0, 1 over 2, 1 over 2, 1 over 2 square root of 3, and this is equals to 1. And you can, for the cosine, you going back from 1 to 0, there'll be 1 over square root of 3, 1 over 2 square root of 2, 1 over 2, and then 0. Can you see that this is tangent? The tangent is like the division of sine and cosine. So this, you get it from right here, right? That'll be 30 degrees. So 30 degree in radian is pi on 6. Yeah. But remember that this pi on 6 is in the first quadrant, yeah? Because we know that previously that this is in the second quadrant, there'll be like 30 degree, but in the second quadrant, right? There'll be, if I go back from 180, there'll be 150 degrees. So this in radian is 5 pi on 6, yeah? So 5 pi on 6. And then when you write down this z again, I mean like this complex number, and there'll be the 10, right, from the modulo, there'll be the, and then chis, yeah, is this guy over here, the angle 5 pi on 6. Okay. So for question D, I would like you to try it yourself. Okay, using the same concept like that, but be careful with the plus and minus. You need to determine the quadrant first before you go to the angle here. You can actually go to the principal angle like I did before here, like 30 degree. Oh, I know that 30, like tangent of 1 over square root of 3 is 30 degree, right, from here. But because it's in the second quadrant, then you need to, yeah, you need to consider that it's in the second quadrant, which is not going to be less than pi on g. Yeah. Okay. Okay, guys, for number 8, I'm going to skip it because it's the same thing like before as the explanation. You only need to change the angle here. It's between theta, negative pi until pi. Okay, so be careful with that. Okay, I'm just going to skip question 8 because you already know how to do it. Okay, let's go to question 9. And we have a complex number. Wait a minute. Okay, determine the complex number in the form of Cartesian form, which is x plus iy from each of these cases. Now we have this. You see that this line here determines that this is the modulus, which is the length, and then we have arg means the argument or the angle that shapes from the real axis. Yeah. Now, this is actually the same thing like before in the previous question about arctis theta, right? So this is like the theta. This is like the r, that's it. So if I want to write down in this form, I will get 4 and in bracket, this is actually, I'm going to write down 4 tis pi on 3. So this can be written as 4, and then c stands for cosine of pi on 3, and then plus as means I sine. Yeah, I is like the complex number I, and then the sine of the angle over here, pi on 3. Yeah. Okay, now if this is a special angle, pretty simple, right? So pi on 3 is the same like 60 degree, so we can write it down as 4 cosine of pi on 3 over 60 degrees 1 over 2, and then sine of pi over 3 is 1 over 2 square root of 3. So it's I times 1 over 2 square root of 3. And then you can like open the bracket like this, right? So 4 times 1 over 2 is just 2. And then 4 times this guy is just 2 square root of 3. And don't forget that we have this item. Okay, now question B, C, D, B, C, and D, all of them are actually the same thing. You can try it by yourself, but be careful that if you have a negative angle, I suggest that you learn more about trigonometry in the previous video. And yeah, see what really happened if we have like a negative angle. Yeah. Okay. Here for number 10, I'm gonna skip it because it's the same thing like before, right, guys? It's just like chis and then also chis, but yeah, I'm gonna go to number 11. Now the question now is you need to change it in the form of Euler form, which is the exponent form. So basically the same thing here. So what we need to do is just find the r value, the modulo, and then also the argument, which is the angle that shape from the real axis. Yeah, so let's do the same thing like before. Now let's find the r value here, which is the modulo, which is this is 1 and this is also 1, so that will be just square root of 1 squared plus 1 squared, which is just equals to the square root of 2. That's the r value. And then the theta, which is the argument, yeah, I'm going to write the argument of that. That'll be just equals to the tangent inverse of y over x, and that'll be just 1 over 1. Can you see that? This is in the first quadrant. Both of them are positive, and you'll see that this is 45 degree over pi on 4. So, which means that question A, the exponent Euler form of this is just 2 square root of 2 from the r, this one over here, and then E, and then I, or you can write down the I later on, or pi on 4 of I. That's it. Yeah, pretty easy. Now the same thing, question B here. Let's do the same thing. Let's find the r first. This is question A. Question B. Now we have the r will be equal to square root of 3 squared and then plus 1 squared. Okay, so this is bigger and then 1 also being squared. Okay, remember it's not this guy. Leave the I alone. This is like the coefficient of I, which is 1. Yeah. So that'll be equals to, that'll be just, this is 3, this is 1, you will get square root of 4, which is just equals to 2. So that is the r value. Now as for the argument, yeah, the same thing like before, we have the first quadrant, yeah, because both of them are positive, so that'll be less than pi on 2, and that'll be equals to tangent inverse of the y, which is 1, and then over the square root of 3. We already did this, right? So the 1 over square root of 3 over here, but this one is negative, but this one is positive. So that'll be just like 30°, right? 30°, it means, but that'll be in radian. So 30° in radian is pi on 6, yeah. So it's equals to pi on 6. So which means that the answer for this one here, that'll be 2, yeah, for the modulo, that'll be 2. And then e to the power of pi on 6i. Don't forget the I. Okay, so that's it. The same thing with the others actually. For example, question number 12. What you need to do is just like multiply. Okay, I'm gonna show you question number 12 like this, right? So basically what we're doing here is the same thing like this, but you need to do this first, yeah, this first. Now be careful that when you understand exponent, this is going to be pretty easy, right? So if you multiply this, you get 2 times 2, which is equals to 6. And if you multiply with the same base, you only need to what? You need to only need to add the power, right? So that'll be just 6, and then e to the power of 0 plus 0.1i plus 0.2i is going to be equals to 0.3i. Yeah, that's it. Pretty easy. Okay, so we can do question A and B for question 12. Okay, so for number 13, factorize these quadratic in the form of x minus a, x minus b. Okay, now this is the same thing actually what we did the factorization, not factorization, like finding the x value, a number, what was it? Here, yeah, number 2, right? Same thing like this. But the only difference is we need to write it down in this form, x minus a and x minus b, yeah? So in here, for example, this one here can be solved like this. So the x value is plus or minus 5i. So you will have actually 2 values of x, right? x1 is equals to 5i, and then x2 equals to negative 5i, right? So if you want to write down like this one over here, you will write it down x minus x1 and then multiply by x minus x2. So this a and b is basically just x1 and x2. Yeah, so you just plug in, right? So there'll be just x minus 5i, right? And then the other one is x minus negative 5i, right? Can you see that negative here can be positive, and it'll be like that. Okay, so the same thing with this one over here. After you find the x1 and x2 like this, just plug in here like this, yeah? But be very careful if you have like 2 terms. So for example, if I have like, for example, x equals to, for example, 1 plus minus 2i, for example, you'll need to write it down like this. X plus I plus 2i, that's the first one. And then x minus bracket 1 minus 2i. So you can see that this is a multiplication. So you might want to open, if you want to open the bracket, it's okay. But if you don't want to open the bracket, that's also fine, yeah? So that's the example for question number 13, as both of them are the same method. Okay guys, so I'm going to skip number 14 to number 23 because all of them are pretty much the same thing. I'm going to go to number 24 here, okay? So given a complex number of z equals to x plus iy, in which you have z to the power of 3 is 8i. So the first question is determine the modulus of z3. So z3 is just z3. So let's rewrite what will happen here. 8i here, you only have the what do you call it, the imaginary part. You don't have any the real part, right? So I can write down z to the power of 3 actually as 0 plus 8i. Right, so as like previously mentioned, let's go back again here for a question. Which one? I forgot. The one that has I forgot which one is it. Okay, I think it's, yeah, this one here, right? So you see that this one is like 0 plus 4i, so the modulus is just 4, right? And then the angle is pi on 2, because we know that a pi on 2 is 90 degrees. So if we going back to the illustration of number 24 here, 0 plus 8i in the Argand diagram is just here, which is 8i, right? So can you see that the angle is pi on 2, right? It's 90 degrees, and the length is just 8, right? So which means that the z is just equals to 8. That's it. Yeah, because if you want to use the what do you call the method that we did previously, which is using the Pythagoras, this is actually just like 0 squared plus 8 squared, and they'll get equals to 8, right? You can see the same thing. Now, as in terms of the argument, is the same thing, right? So the argument is just tangent inverse of like this divided by this. That will be undefined. If the tangent, what do you call it? The tangent of an angle equals to undefined means that the angle is going to be, in this part is 90 degrees or pi on 2, yeah? So 8 divided by 0 is equals to pi on 2. Now, again, but if you understand this concept here, this is going to be pretty easy. So for question, let's go back again to question A and B. So question A is just 8. And question B is just like the angle of this complex number, which is pi on 2. Okay, pretty easy. Equals to pi on 2. Okay, now question C and D. Now the question C and D is like finding the exponential form. Okay, so for question C, determine the z cube in the exponential exponent or Euler form. Now we already know the value of the r and what do you call the theta, so we can write this down as z to the power of 3, yeah, is equals to 8 as the r value, which is 8, and then e to the power of the theta is pi on 2, right? So there'll be just pi on 2, e to the power of pi on 2 I. Don't forget the I, yeah? Okay, pretty simple. Okay, now the next question is question D. Now, in question D, you need to find the z instead of z cube. Okay, now, we know that z cube is from multiplying z by itself 3 times, right? So, what do you need to do to make this guy disappear, or this 1? So, if I have z, that will be actually z cube to the power of 1 over 3, isn't it? Right? Because if I multiply this power, they'll be just equals to 1. So since we already know that the z to the power of 3 is that guy, so I can write it down as 8e to the power of pi onto I to the power of 1 over 3, right? So we know that if we have a power like this, we need to distribute this power here and also here. Now let's rewrite that again. It'll be 8 to the power of 1 over 3 and then e to the power of pi onto I to the power of 1 over 3. Now you see that 8 to the power of 1 over 3 is just 2 because we know that 8 is equals to 2 to the power of 3. So if I have 8 to the power of 1 over 3, that'll be just equals to 2, right? That's it, right? So this is just equals to 2. And we know that this power here, we can just multiply them, right? So there'll be just e pi on 6 because pi on 2 multiplied by 1 over 3 is just pi on 6 of I. Okay, pretty simple. Okay, that's it for the video today. I hope that you can study well before the examination. Okay, good luck.